Okay, let's go through the solutions to the quiz. Number one, you had to set the real parts equal to each other, so 3 equals c, that's fairly simple. And you had to set the imaginary parts equal, so 5 equals 10d, and d equals 1/2. So the solutions were c equals 3, and d equals 1/2. Now for number 2, the real parts are c squared and d, and then 4 and d. So d definitely equals 4. So you can now substitute for d. C squared equals 4, and use the square root property. So c would equal plus or minus 2. And that would make the solutions c equals plus or minus 2, and d equals 4. Number 3, step 1 is to divide both sides by 8. So you get x squared equals -1. Next step, use the square root property. So you get plus or minus the square root of -1. And the square root of -1 is what we're calling I, the imaginary unit. So the solutions are x equals plus or minus I. Number 4, the first step is to subtract 12.5 from both sides, and then to divide by 2. So we get x squared equals -6.25. Using the square root property, we get plus or minus the square root of -6.25. Now that's going to have an I in it because the negative is inside the square root. And it turns out that 6.25 has a nice square root. So the final answer is x equals plus or minus 2.5i. Going to number 5, what we're going to do now is complete the square. So we subtract 44 from both sides. Half of -12 is -6, and -6 squared is 36. So I add 36 to both sides in order to complete the square. The left-hand side now factors perfectly into x minus 6 squared, and the right-hand side becomes -8. Using the square root property and simplifying, I get x minus 6 equals positive or negative 2i square roots of 2, and now I add 6 to both sides, and this gives me my solutions. So for 5, 6, and 7, you could have also used the quadratic formula, and if you had followed the formula carefully, you'd also get these solutions as well. Number 6, we're going to complete the square, so half of -24 is -12. And -12 squared is 144, so I add 144 to both sides. The right-hand side is now a perfect square. It factors perfectly into x minus 12 squared. I now use the square root property, and I get plus or minus I square roots of 5, and then I add 12, and that gives me x equals 12 plus or minus I square roots of 5. Question number 7, it said to find the zeros of the function. So the first thing we do is we set the function g of x equal to 0. So now I have x squared minus 10x plus 37 equals 0. Subtract 37 to the other side. Time to complete the square. Half of -10 is -5, and -5 squared is 25. So we add 25 to both sides. The left-hand side factors into x minus 5 squared. The right-hand side becomes -12. Now I use the square root property, and I simplify the square root of -12. That becomes plus or minus 2i square roots of 3. And lastly, I add 5 to both sides. So x equals 5 plus or minus 2i square roots of 3. The question for 8 was, if I have a quadratic equation with real coefficients, and one of my roots is complex, does the other one have to be complex? Or can I have a quadratic equation with real coefficients that has only one complex root? That was the question. And the answer is no. If the quadratic equation has real coefficients, then the roots, if they are complex, must come in complex conjugate pairs. Must come in conjugate pairs. So that means one of them has to be a plus bi, and the other one has to be a minus bi. Find the complex conjugate of each. In order to do this, you simply locate the imaginary part and you change its sign. So the complex conjugate of -8 plus 3i is -8 minus 3i. In number 10, I rearranged them first. So I wrote pi I minus 5 as negative 5 plus pi I. Since pi I is the imaginary part, this becomes negative 5 minus pi I. And then the bonus question. Part A, FOIL out the following. X times x is x squared. X times negative 3i is negative 3ix. 3i times x is positive 3ix. And 3i times negative 3i is negative 9i squared. The middle terms cancel out, leaving me with x squared minus 9i squared. But I squared, by definition, is negative 1, and so I get x squared plus 9. Part B, solve x squared plus 9 equals 0. So you subtract 9 to the other side, use the square root property, and then simplify. So x equals plus or minus 3i. And then part C, how do you factor x squared plus 9? Well, you simply look backwards to part A and go in reverse. Here's x squared plus 9. What did we start with? This. And so the way that you factor x squared plus 9 is to say x plus 3i times x minus 3i. And those are the quiz solutions. God bless you, wherever you are today.